What is engineering surveying? Engineering surveying involves investigating land using measurement tools and geographic knowledge to work out the best position to build bridges, tunnels, and roads, and others. Producing up-to-date plans which form the basis for the design of a project. Setting out a site so the structure is built in the correct location to the specified parameters. Monitoring the construction process to make sure that the structure remains in the right position and recording the final built position. And providing control points by which the future movement of structures such as bridges and dams can be monitored. And a brief history of surveying. Number 1. Surveying had its beginning in Egypt about 1400 BC. Land along the Nile River was divided for taxation. Divisions were washed away by annual floods. Also, rope stretchers. Egyptian surveyors were created to relocate the land divisions, which is based on the measurements were made with ropes having knots at unit distances. And extensive use of surveying in building of Egyptian monuments. And for Greeks, expanded Egyptian work and developed geometry. Developed one of the earliest surveying instruments. And for Romans, developed surveying into a science to create the Roman roads, aqueducts, and land division systems, where surveyors held great power, had schools and a professional organization, and developed several instruments like groma, cross instrument used to determine lines and right angles, labelia, a frame with a plumb bump using for leveling, curvates, a 20 feet straight edge with oil in knots for leveling. In the Middle Ages, land division of Romans continued in Europe, wherein quadrants were in square brass frame capable of turning angles up to 90 degrees and has a graduated scale developed by an Italian named Von Peso. After the Middle Ages, we have the 18th and 19th century in the New World, wherein the need for mapping and marking land claims caused extensive surveying, especially by the English. And in 1785, United States began extensive surveys of public lands into 1 mile square sections. 30 states surveyed under the U.S. Public Land System, also called the Rectangular System. In 1807, United States Geological Survey founded to establish an accurate control network and mapping. And the famous American surveyors, George Washington, Thomas Jefferson, George Rogers Clark, Abe Lincoln, and many more. And in the 20th century and beyond, as technology advanced, population increased, and land value caused development of licensure for surveyors in all states. Like educational requirements for licensure began in the early 1990s, capable of electronic distance measurement, positioning using global positioning systems, construction machine control, and LiDAR scanning mapping. Involvement in rebuilding of the infrastructure and geographic information systems or GIS, and shortage of licensed professionals is projected well into the 21st century. So these are the history or the brief history of surveying from the Egyptian up to the 21st century. Types of surveying. So for the size of surveying, we have geodetic surveying and plane surveying. And for the positioning of objects in space, we have ground surveying and remote surveying. Purpose of surveying, we have number 1, land surveying, number 2, topographic surveying, number 3, hydrographic surveying, number 4, route surveying, number 5, construction surveying, and 6, mine surveying. And for the categories of surveying, we have geodetic surveying and plane surveying. First, geodetic surveying. Geodetic surveying, when radius of curvature of the earth is taken into account. And geodetic surveying is the surveying technique to determine relative positions of widely spaced points, lengths, and directions which require the consideration of the size and shape of the earth. And for the usages, large area and large distances are covered. Object of geodetic survey is to determine precise positions on the surface of earth. Refined instruments and methods are used and conducted by government agencies. While for the plane surveying, when radius of curvature of the earth is not taken into account. And the meaning? Plane surveying. Surveying with the reference base for field work and computations are assumed to be a flat horizontal surface. Generally, within a 12-mile radius, the pole of gravity is very nearly parallel to that at any other point within the radius, and thus horizontal lines can be considered straight. It is for the small area and small distances are covered. Degree of accuracy is comparatively low, and American Survey put 250 kilometers square for treating survey as plane, but controlling factor should be degree of precision rather than the extent of area. And for the types of surveys, we have photogrammetric, which is mapping utilizing data obtained by camera or other sensors carried in airplanes or satellites. Number 2, boundary surveying, establishing property corners, boundaries, and areas of land parcels. Number 3, control surveying, establish a network of horizontal and vertical monuments that serve as a reference framework for other survey projects. Number 4, engineering surveying, providing points and elevations for the building civil engineering projects. Number 5, topographic surveying, collecting data and preparing maps showing the locations of natural man-made features and elevations of points on the ground for multiple uses. Number 6, route surveys, topographic and other surveys for long, narrow projects associated with civil engineering projects, highways, railroads, pipelines, and transmission lines. And last, hydrographic surveying. It is the mapping of shorelines and the bottom of bodies of water, also known as bathymetric surveying. Measurements and instrumentation. What is instrument? There are two kinds of instruments used in plane surveying. Number 1, linear, and number 2, angular. And for the linear, we have horizontal distance and vertical distances, while for the angular, we have horizontal angle and vertical angle. In surveying, all measurements are horizontal, can be inclined, reduced to horizontal, and vertical components in plotting. And distance between 2 points on a plan or map is always horizontal distance, irrespective of their elevation, distance between their projection on horizontal plane. So this is the inclined distance from point A to point B, and this is the vertical distance, which is the vertical projection, and horizontal distance or horizontal projection. Measurement of distance, we have the horizontal distance, distance between 2 points in horizontal plane, and for the vertical distance, distance between 2 points in vertical plane. While for the horizontal angle, a horizontal angle is the angle formed in a horizontal plane by two intersecting horizontal lines, while the vertical angle, a vertical angle is formed by two intersecting lines in a vertical plane. One of these lines are horizontal. And what is measured? For distances, to calculate areas, volumes, and others. And it is also to draw plans, maps, and others. And for angles, it is both for horizontal and vertical. And for the heights, we have the levels or elevations. How are these measured and which instrument should I use? Well, for the distances based on the horizontal and vertical, the instruments are chaining, taping or tilt tape, theodolite, and electronic EDM or GPS. And for angles, it is theodolite, total station, and level. And for the heights, it is leveling or level, theodolite, and total station. Instruments for measuring distances. We have two main methods for measuring distances, which is linear measurements. We have A, direct method, which is by chain or tape or other instruments directly. And the other method, it is indirect method, and it is based on competitive. Distance is obtained by calculation. Direct measurement. Several methods or instruments are available. Number 1, based on pacing. Number 2, pasometer. Number 3, pedometer. Number 4, odometer. Number 5, speedometer. Number 6, perambulator. Number 7, judging distance. Number 8, time measurement. And number 9, chaining. So these are the methods and instrument, or methods/instruments that are available to be used. And for chaining, most common method is the method of measuring distance with a chain or tape, called chaining. For ordinary work or less precision, chain is used, and for great accuracy, steel tape is used. And for chaining, we have chain, and for taping, we have tape. And for chain is composed of 100 to 150 pieces of galvanized mild steel called links. Links are connected to each other through oval ring for flexibility and provided with brass handle to drag chain. Outside of handle is 0. And length measured from outside of one handle to outside of other handle. And metallic tags are attached to specified distances. Different types of chain. Following are the various types of chain in common use. Metric chains. Number 2, steel band or band chain. Number 3, gunter's chain or surveyor's chain. Number 4, engineer's chain. And number 5, revenue chain. So what is a metric chain? Metric chains are made in lengths 20 meter and 30 meters. Tallies are fixed at every 5 meter length, and brass rings are provided at every meter length except where tallies are attached. So this is the example of a metric chain and steel band chain. And for gunter's chains, the length is 66 feet or 22 yards. Number of links is 100. Each link is equal to 0.66 feet and used for measuring distances in miles or furlongs, or 220 yards or acres or area. And for the engineer's chains, we have the length, which is 100 feet. Number of links is 100, and each length is equal to 1 foot and used in all engineering surveys. And for the revenue chain, the length is 33 feet, number of lengths is 16, and commonly used for measuring fields in cadastral survey. So these are the different types of chains. So metric chains, gunter's chain, engineer's chain, and revenue chain. Errors in length due to incorrect chain. So the most common errors are that the chain may be too long or too short. It will be corrected by using the formula. And the formula, the length of a line is equal to L prime all over L, measure distance, where L prime is the incorrect length of chain, while L is the correct length of chain. If chain is too long, then the measured length will be smaller than the actual. So the error is negative and the correction is positive. If chain is too short, then the measured length will be too long, that is longer than the actual. So the error is positive and the correction is negative. Example: the length of a line measured with the help of 20-meter chain was found to be 634.4 meter. It was found afterwards that the chain was 0.05 meter too long. Find the true length of the chain. So we have the solution. True length of line is equal to L prime all over L times measured length. L prime is equal to the exact length of the chain, which is 20 meter, plus the additional length, which is 0.05, which is longer by 0.05. So 20 plus 0.05, and L prime is equal to 20.05 meter, and the exact length of chain is 20 meter. So the measured length is equal to the given, which is 634.4 meters. So true length is equal to 20.05, which is the L prime, all over L, which is 20, and multiplied by the measured length, which is 634.4, and the value is the true length is 635.99 meter, the true length of the chain. Measurement of distance. For taping, applying the known length of a graduated tape directly to a line a number of times. We have two problems exist in taping. Number one, measuring the distance between two existing points and laying out a known distance with only the starting point in place. And we have 6 steps of taping. Number one, lining in. Shortest distance between 2 points is a straight line. Number two, applying tension. Rear chain is anchor and the head chain applies required tension. Number three, plumbing. Horizontal distance requires tape to be horizontal. Number four, marking tape lengths. Each application of the tape requires marking using chaining pins to obtain total length. Number five, reading the tape. The graduated tape must be read correctly. And number six, recording the distance. The total length must be reported and recorded correctly. And for the types of chains and tapes, invert tapes, which is made of special nickel steel to reduce length variations due to temperature changes. The tapes are extremely brittle and expensive, and it's used most of the time for standard comparison of tapes. Next, we have cloth, fiberglass, and PVC tapes. Lower accuracy and stored on rails, used for measurements of 0.1 feet accuracy requirements. And for the accessories, chaining pens, set of 11, used to mark the tape lengths. Hand level, used to determine required plumbing height. Plumb bob, used to transfer the mark from the tape to ground. And tension handle, used to maintain correct tension on tape. So these are the additional accessories for chains. And for field process, number one, the line to be taped should be marked at both ends. First, keeps measurement on line. Rear chain person should keep the head chain person on line, and 1 foot of line error over 100 feet is equal to 0.01 feet, or the error in length. And number two, we have applying tension. Rear chainman is anchor and should hold 100 feet mark over point, wherein tension is applied by head chain person, normally 12 to 30 pounds of pull, and tapes are standardized at 12 pounds, but greater is utilized to compensate for sag. And for plumbing, one end of tape is raised to maintain a horizontal measuring plane. Only one end is elevated. This allows measurements to be made on uneven ground. If a high spot exists in center, break tape by measuring to the top and then move forward to complete the distance. And for the slope measurements, generally, measurements are made horizontally, but on even, often man-made slopes, the distance can be measured directly on the slope, but the vertical or zenith angle must be obtained. And for the vertical distance, it is equal to sine zenith angle times slope distance. And for the horizontal distance, it is cosine vertical angle times slope distance. So this is the formula based on slope measurements. And for units of measurement, we have the length. For English system, this is for inch, foot, yard. And for metric system, we have centimeter, meter, and kilometer. And the conversion for 1 foot, it is equal to 12 inches. 1 yard is equal to 3 feet. 1 mile is equal to 5,280 feet. 1 inch is equal to 2.54 centimeter. And 1 foot is equal to 30.48 centimeter, or it is equivalent in terms of meter, 0.3048 meter. And for the area, we have the English system, 1 acre is equal to 43,560 feet. And for the metric, we have 1 dunam, and it is equal to 1,000 meters square. 1 hectare is equal to 10,000 square meter, and 1 kilometer square is equal to 1 million meters square. So these are the basic measurement of units based on English system and metric system. on length and area. And for angles, we have sexagesimal, wherein circle is divided into 360 degrees. Each is divided into 60 minutes. Each is divided into 60 seconds. For example, we have 213 degrees, 24 minutes, and 47 seconds. And for the decimal or centesimal, circle is divided into 400 equal grades, or G. Each grade is divided into 100 semal minutes, or C, and each is divided into 100 centesimal, or CC. So we have 128 grades, 60 semal minutes, and 47 centesimal. So this is the decimal or centesimal measurement. And for the radian system, the radian is defined as the central angle opposite to a circular arc whose length is equal to its radius. The whole circle has an opposing angle of 2 pi, or 360 degree angle. For solving problem, we have convert the angle, which is 213 degrees for 24 minutes and 47 seconds, into decimal and radian systems. So solution for angle can be written as 213 degrees plus convert minutes 24 over 60 minutes plus 47 seconds over 3600 seconds, and based on angle, it is 213.4131 degrees. And to convert it into decimal system, 213.4131 degree all over 360 degrees multiplied by 400 grades, and it is equal to 237.1256 grades. And in terms of centesimal, 237.1256 grades is equal to 237 grades, 12 semal minutes, and 56 centesimal. And to convert it into radial system, based on degree, we have 213.4131 degrees all over 360 degrees, and we multiplied by 2 pi, and it is equal to 3.7247 radians. Next problem, convert the angle 115 grades, 2 semal minutes, and 14 centesimal into sexagesimal system. Solution. Angle can be written as 115 plus 2 over 100 plus 14 all over 10,000, and it is equal to 115.0214 grades, and convert it into sexagesimal system, and 115.0214 grades all over 400 grades times 360 degrees, and it is equal to, always multiply by 360 degrees, and it is equal to 103.5193 degrees. And remove the whole number, and the remaining is the decimal points, 0.5193 degree, and convert it into minutes, and then multiply it by 60 minutes. So 0.5193 multiplied by 60 minutes is equal to 31.156 or 1556 minutes. And remove the whole number, which is 31, and the remaining decimal points is 0.1556 minutes, and convert it into seconds and multiply it by 60 seconds. So 0.1556 times 60 seconds, and it is equal to 9.336 seconds. Then the given angle equals 103 degrees, 31 minutes, and 9.34 seconds. So this is the conversion from hexagesimal system to angle.